geometry student to the mid-chapter review for Chapter 6, page 286, numbers 1 through 20. Let's go ahead and jump right into this. Now, we're going to use this figure right here for numbers 1 through 10. Alright, let's fix that real quick. And here we go. This will be a really good review, numbers 1 through 10 on the different types of polygons. What's a polygon? What's not a polygon? Regular polygons, non-regular polygons, etc. So this will be a really good review for you guys. Number 1. Now when they ask us to identify polygons, we're going to do it by angles and sides, if at all possible, okay? Here we go. For example, if I give you a right triangle like this, and it's obvious that all three sides are different, we would call that a right scalene triangle, because based on the angles, it's a right triangle. Based on the sides, none of the sides are congruent. Based on the sides, we call that a scalene triangle. So you can call that a right scalene triangle, or you could call it a scalene right triangle. I'm not really picky about which word comes first. Okay, alright, here we go. Identify the small orange polygon. Now, this orange area here is not a polygon because it has curved sides. This is not a polygon up here because it has curved sides. I see 3 orange polygons. Here's one. That's a polygon. This is a polygon, and this one. It says the small one, so I'm going to assume we're talking about this one. So we're going to identify this polygon. Now it has 6 sides, and by the way, for numbers 1 through 10, usually in geometry you're not allowed to make assumptions about certain things. You have to go by what you know, okay? But I am going to allow you, they want you to, for numbers 1 through 10, to use assumptions on some of these. Just go kind of with the naked eye and just kind of figure things out. So all 6 of these sides look to be the same, okay? So we have a 6-sided polygon. We call that a what? A hexagon. And all the sides are equal, so anytime a hexagon has all congruent sides, we call that a regular polygon. In this case, a regular hexagon. Okay, so number 1 is going to be a regular hexagon. Alright. Okay, moving on to number 2. Identify the green polygon. Now remember, this is not a polygon up here. It has curved sides, so this green area up here is not a polygon. This green area here is not a polygon that has curved sides once again. So the only green polygon that I see is this one right here. And like the last problem we just did, all of these sides look to be the same, and we're allowed to make that assumption. I'm seeing 5 sides. So a 5-sided polygon is called a pentagon. So we know that we have a pentagon. And that might be all, except we notice that all 5 sides are congruent. Put a mark here, a mark here, a mark here, a mark here, and a mark here. All 5 sides are congruent, okay? So if all 5 sides are the same length, we call that a regular pentagon, okay? If all 5 sides were not congruent, then we would just call it a pentagon, okay? Alright, moving on to number 3. Identify the 3 pink polygons, okay? Let's number these, and we'll call them numbers. Number 1, number 2, number 3. Now, I'm gonna go ahead and draw this, and then pull it off to the side. Okay, here's the pink polygon right here. Now, it's not gonna be a perfect drawing, but there it is, okay? Now look at that object, guys, okay? We have yet to study trapezoids. That is a trapezoid. Now, you're not supposed to know that, so don't worry about it. We have studied parallelograms. It's definitely not a parallelogram. This side here is parallel to this side here. However, this side here is not parallel to this side here. So we do not have a parallelogram, okay? We just have a quadrilateral. It's a 4-sided. It's a 4-sided polygon, so we call that a quadrilateral. I think it has 8 sides, and they're all the same, it looks like to me. 1, 2, 3, 4, 5, 6, 7, 8. We have an 8-sided polygon, and all of the sides look to be congruent, just my own estimation. So we're going to have a regular octagon, okay? Because an 8-sided polygon is called an octagon, and it's a regular octagon. Now let's take a look at figure number 3, or polygon number 3. That's obviously a parallelogram, guys. Look, it's a 4-sided figure. This side here is parallel to this side here, and this side over here is parallel to this side here. So number 3 is a parallelogram. Alright, moving on to number 4. Identify the 4 blue polygons. Alright, here we go. We're going to call this 1, 2, 3, and 4. And here we go. Okay, this is obviously, I mean, to me it's obvious all 3 sides are the same. Now, we've learned that anytime you have an equilateral triangle, you also have an equiangular triangle. So, I do not care for this one here. We'll call that number 1. I don't care if you call that equilateral, an equilateral triangle, or if you call it an equiangular triangle. Either one of those would be acceptable, okay? Because anytime all 3 sides are congruent, all 3 angles are congruent in a triangle, or anytime that all 3 angles are congruent, then all 3 sides will also be congruent. Let's take a look at figure number 2. Now, once again, this is, by the way, a trapezoid. We've not studied trapezoids yet. It's obvious we have a 4-sided figure here. Okay, that's obvious. And this side here, just by looking at it, is parallel to this side here. But this side here is not parallel to this side here, so we definitely do not have a parallelogram. It's not a rectangle or a square, so we're going to simply call it a quadrilateral. A quadrilateral, okay? Now let's take a look at number 3. Now this one here, I probably would accept a couple different answers. It's not a right triangle, that's for sure. This side here, some would say it looks to be the same side as this, same length as this side. I don't think it is. But, you know, again, on a test or a quiz, I would make sure that you could tell for sure if the sides were congruent, or I would put a mark here like this, and a mark here like this. But anyways, so in my opinion, it's simply an acute scalene triangle. All the angles are less than 90, and all the sides are not congruent. Now, you could call it an acute isosceles if you want to argue that this side here is congruent to this side here. Again, on a test or a quiz, I'll make it so obvious you'll know, okay? Moving on to number 4. Now we have a right triangle, and this side here looks a little longer than this side here. So I'm personally going to go with the right scalene triangle. And I really think I should have put a triangle here, guys. It's my fault. I really think that's correct. And by the way, if you want to know what the book says, the book has acute scalene for number 3. And they have a right scalene for this figure here at number 4. So I do not think that this side here is the same length as this side here. But again, if you think it is, you could put right isosceles. I'm not going to argue over that, okay? But those are the 4 shapes, okay? Moving on to number 5. Find the sum of the interior angles of EFGHI. So let's kind of connect the dots here. E, F, G, H, I, and then back to E. Now, I'm going to pull this out of the way. There it is. Well, there it was. So, count the sides. 1, They just want us to find the sum of all 5 angles. Angle 1, 2, 3, 4, and 5. Well, we learned a formula for that, didn't we? 180 times n minus 2. N being the number of sides. Sure we did, we learned that, guys. This is a 5-sided polygon. So we have 5 minus 2. 5 minus 2 is 3, so we have 180 times 3. It's 540, okay? So I do not know, and neither do you, what each of these angles are. However, if you add all 5 of these angles up, it will equal 540 degrees, okay? So anytime you're asked to find the sum of the interior angles of a convex polygon, this is the formula you want to use. If you don't know that, you need to know that. Alright, number 6. Find the sum of the exterior angles of BEIC. Now, I'll go ahead and highlight BEIC, but it's really not necessary. Because we've learned that the exterior angles of any convex polygon, the sum of them is always 360. Please memorize that, students. That's such an easy a problem to have on a test or a quiz. If I ask you to find the sum, that means you're adding them all up. The sum of the what angles? Exterior angles of a convex polygon. It's always going to be 360. Always. There's no work to show. There's no math to do. Number 7. What is the measure of each interior angle of the small pink polygon? Now, let's take our time and work on this. Here's the small pink polygon right here. Okay? So with that in mind, I think that's a octagon. I don't think they give that one to us. No, they don't. We'll see if we can draw it real quick here. Yeah, I didn't think so. I completely give up on being an artist. I have no skills. Alright, we'll draw it over here if at all possible. Because I want to show you guys some stuff on here you need to see. Alright? And alright, there we go. Now, here's my 8-sided figure, my octagon. Now remember, listen students, anytime you have a regular polygon like this, the angles are also going to be congruent. Now I can prove that to you by drawing a triangle here, okay? And then drawing 8 triangles, and then going around and finding the interior angle, and then using side angle side and proving to you. But I'm not going to do that, just trust me. If you have a regular polygon like this, these angles will all be congruent. Now, how many sides does this polygon have? 8. So how many angles does it have on the inside? 8. So here's what I'm going to do. I'm going to find the sum of all these angles. Here's my formula. N minus 2. So for my n right here, I'm going to put an 8. 8 minus 2 is 6. So 180 times 6 would be 0. 48 carry your 4, 1080. So if I add up all 8 of these angles, 1, 2, 3, 4, 5, 6, 7, 8, if I add them up, I'm going to get 1080. So how would I find the measure of just 1? Well, I can divide by 8 because each of the angles are congruent. So I'll divide by 8, that's 1, 28, 3, 40, 5. So each of these angles is going to be 135 degrees. If you add all that up, you will get 1080. Alright, 135 degrees. Moving on to number 8. measure of each interior angle of the green polygon. Great practice, is really good for you guys, okay? Please look at this. Okay, we'll make this green polygon a little bigger. There it is. Now look, we have 5 sides. Do you see that? 5 sides. So, if I want to find, if all of these sides are congruent, which they are, then that means all of these angles here will also be congruent. Okay, all 5 angles. So, here's what I'm going to do. I'm going to find the sum of all 5 of these interior angles. If I have 5 sides, I have 5 angles. So my formula is 180 n minus 2. There's 5 sides, so I'll put a 5 here. 5 minus 2 is 3. 180 times 3 is 540. So there, if I add up all 5 of these angles, I'll get 540. So to find the measure of one angle, just divide this up by 5 because all 5 angles are congruent, and you will get 108 degrees. So each one of these angles right here is 108. If you were to put 108 in all of these angles, add them all up, you would get 540. Okay? So the measure of one angle is 108 degrees. Number 9. What is the measure of each exterior angle of the small pink polygon? Okay, once again, here's our small pink polygon. Now, I really would like to draw this. I feel like it's important to do that. Unfortunately, I'm just not able to draw. I'll try it one more time because I really want to show you guys some stuff I think you need to see. Wow, that's amazing. I need to quit teaching math and do art class. Alright, now watch this carefully. Look. What I want to show you is how many sides does this have? 8, obviously. Okay. How many interior angles does it have? 8. Well, guys, how many exterior angles does it have? 8. 8. Watch, I'll show you. You go to one vertex, extend aside. Go to this vertex, extend aside. Go to this vertex, extend aside. Every vertex, you extend one side. Okay? So each vertex only has one exterior angle. Okay? Like the exterior angle here would be this, right here with the dot. Here's the next exterior angle. Here's the next one. Here's the next one. Here's the next one, etc. So, now think about this for a second, guys. I know all of my angles don't look congruent on the outside here. All of my exterior angles. But that's because I'm a poor drawer. Okay? All of these exterior angles are congruent because all of the interior angles were congruent. So the exterior angles have to be congruent also. So I have 360 divided by 8 because there are 8 exterior angles. And you'll get 45 degrees. Okay? 45 degrees. Alright? Okay, moving on. Number 10. Same thing again, guys. I'm not going to spend a lot of time on this. Look. What is the measure of each exterior angles of the green polygon right here? Well, guys, that's a pentagon. Okay? I can draw that. I've got help on this. There we go. Alright, there's my pentagon. Now, look. Once again, how many sides? I want to drill this into your heads, guys. Learn this. How many sides do I have? 5. How many interior angles do I have? 5. How many exterior angles do I have? 5. Now listen, these angles are not always congruent, but in a regular polygon they will be. These exterior angles are not always congruent, but in a regular polygon they will be. Okay? So if I extend one side at each vertex like this, I'm going to have 5 exterior angles. Okay? 5. Here's 1. Here's the next one. Here's the next one. Here's the next one. And here's the next one. Okay? So, what's the sum of the exterior angles? It's always 360. The interior angles is when you have to use this formula here. Got it? Exterior angles use 360. Well, there's 5 angles. So if you divide 5 into 360, you get 72 degrees. So all of these exterior angles here are 72 degrees, every single one. Okay? 72 degrees. Alright, moving on to number 11. Draw a parallelogram that has 2 obtuse angles. Very simple. Very, very simple to do, guys. Now, this angle here is definitely bigger than 90. And this angle here is definitely bigger than 90. There it is. Alright. A parallelogram that has 2 obtuse angles. These angles here are acute angles. They are smaller than 90. So there it is, a parallelogram with 2 obtuse angles. Now, can you draw a quadrilateral that is not a parallelogram and has 2 obtuse angles? Well, of course. Look, guys, listen to me carefully. Back here, your 2 obtuse angles were across from each other diagonally. Okay, they were vertical angles, not vertical. They were across from each other. Okay, now opposite. That's right, opposite. They were opposite angles. Well, in this time, just draw your 2 obtuse angles so that they're adjacent or side by side. Watch. Here's my base. Now draw an obtuse angle here, there. Draw an obtuse angle here, there. And then connect these 2 sides, there. Now, that is a quadrilateral. Has 4 sides. 1, 2, 3, 4. It's a quadrilateral. It's not a parallelogram. This side's parallel to this side, but this side is not parallel to this side. And it has 2 obtuse angles. This angle's definitely larger than 90. This angle's larger than 90. This angle's less than 90. And this angle's less than 90. Okay? So that's a quadrilateral with 2 obtuse angles. That's not a parallelogram. Alright, number 13. Can a quadrilateral have 3 obtuse angles? Yes, it can. Most definitely, yes. We can start off by drawing, let's see, we'll draw a side here, then we'll draw an angle here that's bigger than 90, then we'll draw another one that's bigger than 90, like this. Alright, now, okay, students, I'm back. I paused the video. I was working on this. I don't like to sit there and play around with stuff while you guys are listening and waste class time. Let's do this. Everything's fine with what I've done so far. We drew a line up. Make sure this angle's bigger than 90. Make sure this angle's bigger than 90. Now, the only thing I would do differently is on this angle here, I think I would make it just barely over 90. Like, there's 90. That's approximately 90 degrees. So I'm going to draw the angle a little wider, just a little wider than 90. There. Now, remember, this would be 90 right here. I'm going to make it wider than that and swing it just, this would be 90, and we'll go just a little wider, about like that. Now eventually, these 2 lines would intersect down here, okay? They would. So, I know I've bent them a little because I'm running out of room, but they would eventually intersect because their slope is leaning toward each other, but this is bigger than 90, this is bigger than 90, this is bigger than 90, so not the best drawing in the world, but you get the point. Yes, it is definitely possible to draw a quadrilateral with 3 obtuse angles, definitely. Alright, number 4. How many pairs of supplementary angles does a parallelogram have? Now, guys, we should know this pretty easily here, okay? Now, this angle here, let's go 1, 2, 3, 4. These 2 angles are supplementary. So angles 1 and 2. These 2 angles are supplementary. So angles angles 2 and 3 are another pair. Angles 3 and 4 are supplementary. So angles 3 and 4. These two angles are supplementary. So angles 1 and 4. So how many pairs of supplementary angles do we have? 4. Okay? 4 pairs. And some parallelograms would actually have 6 pairs. A rectangle is a parallelogram. Okay? And so these two would be, these two would be, these two, and these two. That's 4 pairs. And then these two would be supplementary, and these two would be supplementary because they're 90 and 90. But that's not true with every parallelogram. So, how many pairs of supplementary angles does a parallelogram have? 4. For the most part, 4, unless it's a rectangle. And by the way, a rectangle is a parallelogram. Not every parallelogram is a rectangle, but every rectangle is a parallelogram. But most parallelograms will have 4 pairs of supplementary angles. Alright, 15 through 18, here we go. Now first of all, look at this figure they've given you. This side is parallel to this side, and this side is parallel to this side. So we know for sure that we have a parallelogram. I hope everyone sees that. That's really, really basic. Okay, if you have a quadrilateral in which both pairs of opposite sides are parallel, then you do have a parallelogram. So if we if we have a parallelogram, then that means this figure takes on all the characteristics of a parallelogram. So PS is congruent to QR. Here's PS. Here's QR. One of the characteristics of a parallelogram is opposite sides are congruent. So yes, that's true. I have a parallelogram. So opposite sides are congruent. Number 16. SPQ. This angle right here. I'll highlight it like this. This angle right here is congruent to angle PQR. PQR. No, that's not true. In a parallelogram, consecutive angles are supplementary. Now again, if you have a rectangle, that's a little different. We're talking about a normal parallelogram. No, angles that are side by side, consecutive angles, are not congruent. They are supplementary. So no, that is false. Number 17, angles PSR. This angle here, PSR, and angle PQR are congruent. Well, of course that's true. If you have a parallelogram, then opposite angles are always congruent. This angle here is congruent to this angle here, and this angle here is congruent to this angle here, so definitely, yes, that's true. And then lastly, number 18, PR is a diagonal. QS is a diagonal. They bisect each other. Is that true? Yes, that's true, guys. Anytime you have a parallelogram, their diagonals always bisect each other. Now, it doesn't mean they're congruent. It means this segment here is congruent to this segment here, and this segment here is congruent to this segment here. Okay? Alright, on to these last two and we'll be done. Now, I know proofs are not really something you enjoy doing, but guys, I'm going to tell you, these are not difficult proofs. I'm just going to be honest with you. Now, if you don't get them, I don't want you to feel dumb. I'm just saying, though, these are really reasonable. I would give you these on a test easily, okay? So take some good notes, pay attention, see if you can get better on these, okay? I'm going to go ahead and put a 1 here, put a line, and put my given. That's my given, okay? Now, I am given that I have a parallelogram. PQRS is a parallelogram. I'm also given that PT, this segment here, is congruent to UR. They want me to prove that QT, this here, is congruent to SU. Guys, we're basically done. Learn to think and, what we've learned in the past. See this triangle here? If I could state that that triangle right there is congruent to this triangle here, then I could definitely state that this side here is congruent to this side here. And that's my goal. QT congruent to SU. So if I can state that these two triangles, triangle number 1, triangle number 2, if I can state those two triangles are congruent, then I'm basically done. Well, look how easy it is to state that these two triangles are congruent. I'm just brainstorming here, okay? But look, this side here is already congruent to this side here, right? Now we have a parallelogram that's given to us. So if you have a parallelogram, opposite angles are congruent. So I can definitely state that this angle here is congruent to this angle here. And then also in a parallelogram, opposite sides are congruent. So PQ is definitely congruent to SR. I've got side, angle, side, congruent to side, angle, side. So here's what I'm going to have to do in my proof. Are you ready? Here's what I'm going to have to do. First of all, somewhere in my proof, I'm going to have to state that angle P is congruent to angle R. Okay, this angle, this angle. Somewhere in my proof, I'm going to have to state that PQ is congruent to SR. This side and this side. And I've already stated this right here. It's in my given. I already stated it in my given right here. Okay? So let's give this a shot and see how we do, shall we? Here we go. Okay, number 2, I'm going to go ahead and state that angle P is congruent to angle R. And the reason is opposite angles of a parallelogram are congruent. Easy enough. Number 3, PQ is congruent to SR. Well, that's easy. What's the reason for that? Opposite sides of a parallelogram are what? Congruent. So I'm going to pick this up and put it over here. I've got this side congruent to this side. I stated that in my given. Step 3 said this side is congruent to this side. Step 2 said this angle is congruent to this angle. I've got side, angle, side. So now I can definitely state that my triangles are congruent. Now draw your congruencies very carefully. Triangle PQT is congruent to triangle. Now be careful. What came first here? Angle P with 1 mark. So what comes first down here? Angle R. What came second? Q. So angle Q is on the end of the 1 mark, then travel down the 2 side to Q. So angle R is 1 mark right here, where it's supposed to. Travel down to S, so S would come next, and then RSU. There it is. How can I state that? Side, angle, side. And now, I'm trying to state that QT is congruent to SU. Well, look right here. Here's QT. Here's SU right there. I can definitely state that QT is congruent to SU. And the reason would be CPCTC. Corresponding parts of congruent triangles are congruent. Really not that bad, guys. Okay, number 20 and we're done. It's basically the same thing, only a little more challenging. Here's my statements. Here's my reasons. Alright? Now, here we go. I do have a parallelogram that's given to me. I'm going to put a 1 here. Put my line. I'm not going to recopy my given. All of my given is up here. Angle 1's congruent to angle 2. They didn't mark that for me, so I'm going to mark it, okay? Got to mark that. I've got to mark that. There. Now, I'm trying to prove that this triangle here, STW, is congruent to this triangle here, UVX. Alright, so let's see what I have so far. Are you ready? I know so far I have angle 1 congruent to angle 2, but hold it. I'm dealing with a parallelogram, so I know ST is congruent to VU. So somewhere in my proof, I'm gonna have to state what? ST is congruent to what? VU. Somewhere I've got to state that. Now that's easy to do because I have a parallelogram, but I still got to state that somewhere over here. Wow. I mean, this is tough, guys. I've got an angle and a side and that's it. But I just had a thought. Okay, I don't have many of those. I just had one. This side here is parallel to this side here, right? Do you see that? And see this SU, if I extended it, it would look like this. Got it? See that? So I'm going to copy that over here. Watch. Parallel line, and a transversal coming down like this. guys, we've learned that when you have two parallel lines cut by a transversal, alternate interior angles are congruent, correct? Now, the one thing I don't like my drawing here. I should have made my line a little more slanted. Like this. Let me make it a little more slanted like that. There, that's better. Kind of matches that line. So guys, look, this is alternate interior. See this angle right here is congruent to this angle here. Well, where is this angle over here? It's right here. Where is this angle over here? Right here. Look at that. So I can state, let me erase all this so you can see it better. I can definitely state, we know this angle here is congruent to this angle here. That's given to us. I can definitely state this angle here is congruent to this angle here. What's my reason? Alternate interior angles. Alternate interior angles. And then look, I know this side here is congruent to this side here because opposite sides of a parallelogram are congruent. I've got angle side angle congruent to angle side angle. So let's list everything over here that I'm going to have to put into my proof. I'm going to have to list this. Somewhere I'm going to have to list that ST is parallel to VU. I've got to state that because next I'm going to state that. Let's give these angles some numbers. Let's call this angle 3 and let's call this angle 4. Somewhere in my proof I got to state that angle 3 is congruent to angle 4. But I can't do that until I state I have parallel lines. I think I'm ready, guys. Okay, let's mark this picture as we do things, okay? Watch. Here's my given. Got it? Here's my given. In my given, I have 1 congruent to 2, so mark that. 1 congruent to 2. Okay, next I'm going to state that ST is congruent to VU. And I can do that because I have opposite sides of a parallelogram are congruent. Let's mark that, okay? There, there. Now, step 3, I'm going to state that ST is parallel to VU. How can I state that? Definition of a parallelogram. If I have a parallelogram, I know the opposite sides are parallel. Okay? Now, if I state that this side here is parallel to this side here, remember, I can then state that this angle here is congruent to this angle here because they're alternate interior angles. So now I can state angle 3 is congruent to angle 4, and my reason is alternate interior angles of parallel lines are congruent. And now I've got it all marked here perfectly. Angle side angle congruent to angle side angle. So I've got triangle STW congruent to triangle UVX. And the reason would be angle side angle. Okay? Guys, I really hope this has made sense. I hope this has been a good review for you guys. If you have any questions, don't hesitate to call or email.